walking so close to the edge.
Hello and welcome to the practice problems video for the definition of the derivative. Alright, so for this problem we're going to compute f prime of 2, so the first derivative of f evaluated at 2, in two ways for f of x is equal to x to the third. Okay, so what are these two ways? So first of all, we've learned two different definitions of the derivative. A lot of alliteration going on there. So the first one is that f prime of a is equal to the limit as x goes to a of f of x minus f of a over x minus a. So that's the first one. And then the second way will be f prime of a is equal to a different limit. And we just rephrase things differently, right? So f of a plus h minus f of a over h. Okay, so we'll do the first method first, as is conventional, right? So let's set it up. So we have that f of x is equal to x to the third, and we want to find f prime of 2, okay? So this first method, I'll just label it a 1 at the top. So this is going to be f prime of a is equal to limit as x approaches a, as x gets closer and closer to the x value of a, of f of x minus f of a over x minus a. Okay, so what we have to find is, so we already have our f of x, right? We can just plug in an x to the third. What's our f of a? And what is a, anyways? So our a is given by the problem. A is equal to 2, okay? So we can just plug in a 2 for this a. So f prime of 2, that's what we're solving for, right, is equal to limit as x goes to 2 of f of x, x just stays in x, minus f of 2, we're plugging in for a, and then an x minus a 2, okay? So let's now use our f of x equals x to the third to make these into actual equations, okay? So what we'll have is limit as x approaches 2 of f of x, which is just x to the third, minus f of 2, so if we plug in a 2 in for x, we get 2 to the third, and this is over x minus 2. Okay, so if we keep working with this, we get that the limit as x approaches 2 of x to the third minus 2 to the third, that's a difference of cubes, right? So we can actually break this up into x minus 2 and an x squared, and then plus a 2x plus a 2 squared, so that would be a 4, okay? So something like that, and then we have that, all of that over x minus 2. Alright, so see how on top and bottom, now we have this x minus 2 term that we can cancel out, that grouping there. So that's good. We just removed a removable whole, or also known as an indeterminacy, okay? So now all we have to do is evaluate the limit as x goes to 2 of x squared plus 2x plus 4. And we can do so just by directly substituting a 2 in for the x, because we know that this function, this value, for f of x is continuous at 2. Okay, so we can just plug in a 2 in there. So 2 squared plus 2 times 2 plus a 4 is going to be 4 plus 4 plus 4, which is going to turn out to be a 12. Okay, so this is what we get for our value of f prime of 2. So the first derivative evaluated at 2. Okay, so that was the first method. That was using our x and a, right? Now let's do it the second method way. Okay, so second method, so here again is our f of x. That's x to the third, and we want to find x, or f of f prime of 2. Okay, so let's write down, what do we know? So f prime of a, using the second way, is going to be limit as h, this is the h1, h goes to 0, of f of a plus h, and then minus f of a, and then this is all over an h. So here we note that our a, again, is 2, but for now, I think we can hold off on plugging in 2 until a later time, or not too much later, but later in the problem, okay? So here, let's rephrase these top things in accordance with f of x is equal to x to the third. So what we're going to get is limit as h goes to 0, f of a plus h is now a plus h to the third, okay, according to our formula, to our given function, and then minus f of a, that would just be an a to the third, and this, of course, is all over h. So if we expand this out, let's see what we get. So limit as h goes to 0, this is going to turn out to be an a to the third plus 3a squared times h plus 3a times h squared plus an h to the third. And then this is minus an a to the third. And this is all over an h. Okay? So here we can see that we can cancel out this positive a to the third and the negative a to the third, which is good. And then on this last line down here, for this slide, I'm going to write, I'm going to factor out an h, the h's that are left. So this could be h times, what, 3a squared plus 3ah plus h squared, okay? And this is all over an h. So we can see that now that we factor that out, we can cancel the top and bottom h there. Okay, so I'll continue this on the next slide. So what we're left with was limit as h approaches 0 of 3a squared plus 3ah plus an h squared. Okay, so at this point, we can actually just plug in our h equals 0, or a 0 for the h spot, because we know this function here is continuous at h equals 0. So this is going to be a 3a squared plus 3a times 0 plus a 0 squared. So these terms go away, they go to 0, and we're left with 3a squared as our f prime of a. Okay, so I'll rewrite it like that. Okay, so now all we need to do, like I said, we know that our a is equal to 2, so what we can do to find f prime of 2 is now just plug in a 2 for the a spot. So this is going to be 3 times 4, which is equal to 12, right? So even using the second method, and not even, but it should work out that way. So this is equal to our f prime of 2, which was the answer we obtained from using the first method as well.
I'll give you my virtue, just give me time. Let me swim the whole night, the whole night.